Welcome back, guys. We're continuing our work with 3.4, and we did number 30. Then comes 34. Oh, 34 is fun. We'll see. Thirty-four is a lot of fun. No. Okay, it's not really that bad. 1 minus cosine square theta. I like to take the complicated side. It happens to be the left-hand side, clearly. I would like to simplify it. That's how I handle these problems. So instead of 1 minus cosine square theta, I can simply write sine square theta. Why? The trig identity, the first orange trig identity on my right. And with the rest, oh, let's do it now. Instead of cotangent square theta, I can write cosine square theta divided by sine square theta. Why? Because cotangent is cosine over sine, and I have square, I keep the square. Now, when you distribute this, when you multiply this by 1, you're going to get sine squared theta right here. When you multiply this by this, sine squared theta and sine squared theta will cancel. That's exactly what I'm going to do. I'm going to get rid of my mess. It's a little bit of a distraction here. I'm going to say, okay, when I multiply sine squared theta by 1, I get sine squared theta. And when I multiply sine squared theta by the next big expression, sine squared theta they get canceled, and I get this. And look how nice this is. Sine squared theta plus cosine squared theta is clearly 1, the very first trig identity. I can now say, oh, that's easy. 1, and that's the right-hand side. Done. I'm going to pause just a little bit, okay, guys? And I'm going to see how my file is doing. All right, it's doing fine. All right, let's move on. So we did 30, we did 34. What else? 35. Okay, let's try 35. All right, that's also a good one. Okay, before we started our session, I picked some of the problems from your book. I tried to make sure the ones that are different, and I wanted to make sure that I do the easy ones first, and I did. Now these are getting, I would say, a little more challenging, but I'll let you be the judge. All right, guys, so I'm going to use these formulas to foil this and foil this. And I'm going to keep my fingers crossed. Hope I get two. We'll find out. If I foil this using a plus b whole square, the green one, the green formula, what happens? The left-hand side becomes sine square theta plus cosine square theta. And you can write 2ab. I'm going to put, well, sure, most of you are probably more used to writing it this way. I'm going to do it the way you guys are more used to. So far, guys, what I did is expanded this using this green formula. Then I'm going to use the blue formula in this, on this slide. Blue formula, applied the blue formula here. And what do I get? I get something very similar, guys, if you observe. So I'm going to copy paste. But there's a minus sign here. A minus sign here. Well, that's very nice because I can cancel them. I can cancel this and this. It's not bad. Can't complain about that. That's exactly what I'm gonna do. I'm gonna say, okay, plus 2 sine theta cosine theta is gone. And minus 2 sine theta cosine theta is gone with it. Now, things are very nice, guys. Very nice. Using the first trig ratio, the blue one right here. Sine squared theta plus cosine theta is 1. Using the same formula again on the next part, we get another 1. 1 plus 1 is 2. That's the right-hand side. Done. We proved it. It's a bit too long. I know they're overlapping, but I hope that's not too bad. Okay. Any questions, guys? We're making some progress. 37. We have like 3 more problems. I'll do them all, okay? 37. Let's try 37. 37. All right, so this one, okay. We don't see to the power 4 a lot, but the good news is you can, for this one, guys, you have to do the left-hand side and the right-hand side. Well, we'll see. I'm going to start with the left-hand side, guys, okay? Left-hand side. I am going to factor out secant squared theta. I can do that because they're in both components. If I factor out secant squared theta, I'm left with secant square theta minus 1. Now, that's not bad. Secant squared theta minus 1 is what? It's tan squared theta. So now I can say this is secant square theta, and secant square theta minus 1 is tan square theta. Okay, I'm getting there. I'm getting there. Now, what is secant square theta? Instead of this blue secant square theta, I can also write 1 plus tan square theta here. I want to convert everything to tan because my right hand side is all tan. Things are looking much better. Now I'm going to multiply tan squared theta with tan squared theta. I'm going to get tan to the power 4 theta. And then I'm going to multiply, I'll talk in a second. Tan squared theta times 1 is tan squared theta. And we have it. Look what we found. This is equal to 1. Sorry, right hand side. We proved it. And pause there just a little bit, okay? All right, guys, moving on. 37, 44, 45. Okay, let's see what's going on. 44, 45. Let's try those. Okay. And I assigned the problems. Okay. If you understand some of the ones I'm doing, you could be able to do the ones in your book, of course, on MATLAB. If you cannot do the ones, some of the ones from MATLAB, you just email me. Okay. All right. So this one, how do we do that? All right. So the way I see this problem, guys, on the left-hand side, I have a mess. I'm going to simplify the left-hand side as follows. And ideally, I want to convert everything to cosine. So instead of sine squared theta, I can write 1 minus cosine squared theta. Okay, a little bit of work. Now we're going to use this. A minus b times a plus b is a squared minus b squared. One can be written as 1 squared. Now I can use this orange formula here, okay? The orange formula. And I can write this guy, 1 minus on top, I'm going to get 1 minus cosine squared theta. 1 square minus cosine squared theta is 1 plus cosine theta. And 1 minus cosine theta. And then that's good news because I can cancel. I can do some cancellation. This guy and this guy, they're the same. So what am I left with? I am left with 1 minus 1 plus cosine theta. Now, when you remove the parentheses, this minus will make this minus 1 and minus 1 and 1 will be gone. And this minus and this plus will make this negative cosine theta. And you have it. That's your right-hand side. And that's exactly what you were hoping you would get. Give me 1 second. Let me write it down. So we have it. All right, guys, one last problem. Okay. 45. Let's see what 45 looks like. Okay. That's a good one, actually. It's probably the hardest one. All right, so let's see. I'll do it slowly. All right. So it's a little hard, guys. Okay. I, of course, actually, it's not that bad now that I see it. Okay. So I'm going to start with the left-hand side, or let's do this one with the right-hand side. Okay. I'm going to start with the right-hand side. Right-hand side. Hopefully, I'll get to the left-hand side. Now, instead of they're writing cotangent V. Instead of cotangent V, I can write 1 plus 1 over tan V. Why? I'm just gonna, if you don't mind, I'm just gonna write tan V plus 1. And the bottom part is gonna be, I'll fix that, okay? So it seems like there is a little typo, but we'll address it. Don't worry too much. I'm gonna write tan V minus 1. And on top, I'll get tan V plus 1. Now, why did I do that, guys? I want the right-hand side to be converted to the left-hand side. You could have started with the left-hand side, and if you did, you would be replacing tan V with 1 over cotangent V. Why can we do that? Because they're reciprocals. Now, I'm going to come here. My denominator is not the same. So instead of 1, I'm going to write tan V over tan V. Same thing with the bottom part. Now I have good news. The top part has 10b, 10b as the denominators. The bottom part has 10b, 10b as the denominators. That's not bad. That's something I like. So on the top, I'll get 10v divided by, don't worry, I'll fix it, okay? 10v divided by 10v. And here I'm going to get 1 minus 10v. Why? Because 1 minus 10v, the denominators are the same, they come here. Same kind of a deal with the top part. But the top part has a plus. Now I have good news for you guys. I can cancel 10v and 10v. And what I'm left with really is this exact same thing, if you can make that connection. So this thing, after cancellation, turns out to be what I was hoping it to turn out to be. Done. And that is my left-hand side. I proved it. You could have started with the left-hand side. You would just have to convert everything to cotangent by using the reciprocal. Take a look. Tell me what you think. So guys, I don't have any more to do from this section. We're kind of done with 3.4 and we'll try to work on 3.5 tomorrow. And that'll be the cutoff line for our exam 3. So guys, I'm going to wrap up this session, shut it down. I will hang around. I will log on again and I'll be here for another 30, 40 minutes. If you have any questions about anything, I'll be happy to help you. So if you want to come back, be my guest. Otherwise, we'll move on. Thank you, guys. I'll either see you tomorrow or at the next session, but nothing will be recorded. Bye-bye.